Hello and welcome to my presentation on visual disabilities in chemistry. My name is Douglas Martinich. I'm one of the asynchronous graduate students. Thank you for taking the time out to listen to my presentation and hopefully learn a little bit about blindness and maybe science classes in general, not just chemistry. One of the things I want to bring up is the fact that for myself, blindness or color blindness, any vision impairment had actually been on my mind ever since I started chemistry, and that's because when you go through chemistry, you never really see anybody with a vision impairment. Maybe they have glasses or something, but otherwise you really don't see anybody with a disability at the higher levels. So it was something that had intrigued me, and finally this class allowed me to explore that. And one of the articles that I looked at surprised me. It was the Michael Warler's article about blindness, low vision students, and it pointed out that of the 10.4% of workers with disabilities, there are only 2.7 that are involved in science and engineering. That is a really, really low number. And looking back, it made a little bit of sense, but at the same time, it was shocking to me. And the reason for this shock was the fact that I had never really thought about it consciously before, and at the same time, it made me wonder what has been done to help students who have these vision disabilities to become a part of a scientific community in a way that gives them independence. And that actually led me to also look into color vision deficiencies such as red, green, color blindness, or even total color blindness, which is very rare. And I found another article, and it estimated that 0.5% of females and 8% of males do have a color vision deficiency, and it went on to state that if you had 1,000 students in a classroom, you are more than likely going to encounter a small portion that are colorblind and might need help. So first we're going to get into the blindness or low vision students and what that effect has on them being able to perform chemical labs and do it in a way that they still get the experience of being able to be a scientist. One thing to note, chemistry requires a lot of visual cues. One of the first things that you are taught in chemistry is wear your goggles because your eyes are important. The importance of vision in chemistry is summed up with that, because you need to be able to measure volume by looking at the side of a graduated cylinder. You need to be able to see to light a Bunsen burner. You need to be able to observe with your eyes, and it is such a visually dominated system. The problem with this visual dominance as the main observation point for chemistry is the fact that none of the instruments have built into them visual impairment aids to help students with visual impairment. A good example is mass spectrometers. These mass spectrometers, they are visual instruments. You have to be able to look at a computer monitor and watch lines go up and down on a graph to know what's going on in them, and you have to be able to interpret that visually in order to get the answer you're looking for, and there is no aid built into this for visually impaired students. At the high school level, this goes down to your graduated cylinders. Maybe something's going to change colors. Well, these students, there's no built-in aid into a lesson plan that might help them. They don't have the encouragement of an aid to allow them to be interested in chemistry, and it's kind of sad because chemistry is really fun. What was really cool about the Michael Warler's article on the blind and low vision students was the fact that there was a case study in there. And in that case study, a student was able to complete a Chemistry 100 course, which is the college equivalent of a high school chemistry, almost completely independently with some aid from teaching assistants or aides that do like text to speech, but it was color to speech. One of the other things that the article talked about was The fact that the student was able to navigate the laboratory as long as it was set up the exact same way every time, they were able to find glassware, find the safety equipment, all because it was always in the same place, and it gave them the confidence to be in the lab. And confidence, it was a huge factor, it turned out, for this student in the lab. And that was important because one of the parts that the student was scared of was lighting a Bunsen burner, and that was because they couldn't see it and they wouldn't feel it until it was lit. However, with the assistance of a teaching assistant, the student was able to light a Bunsen burner and gain confidence in their ability to do that. And as such, they were able to focus on other parts of the lab and not worry about lighting the Bunsen burner after they learned how to light one. A lot of the tools that this student used were modified house lab equipment. House lab meaning equipment found normally within that laboratory. And using tape, a pipette, and a graduated cylinder, the student could measure exact quantities if it was set up correctly. However, what the article pointed out was the fact that many of these home brewed remedies for the student have not been tested extensively and to see how reliable they are for every student. Now, despite this, the article in the end concluded that these homebrewed remedies to get these students the ability to be in the lab are what is needed, but they need to be taken from in lab made to being made outside of the lab in a professional setting, so that these students can have access to a professional grade aid that can help them and give them the encouragement they need to try and become scientists. Moving on to color blindness, while I was reading the blind low vision student article, I got very interested in color blindness as well, because color blindness, we've all probably heard of it, and it also has an effect on chemistry, even though the student can still see. Part of the problem arises from the fact that many instruments that are used in chemistry do in fact also require you to be able to see color, whether that's a titration, a precipitation, which is the falling out of material from when you mix two liquids, or a flame emission, you're just burning something and see what happens. In the case of the flame emission, different compounds, elements, they all release a different color when you burn them. And great example of this is some of them burn green. Well, if somebody is red-green colorblind, they are going to have a very hard time with this lab because they're not going to be able to see the true color that is actually being produced. This also goes for titrations. Titrations are the ones that are very difficult, and in a titration reaction, you're looking for the most minuscule color change when it's going on. And again, if a student's colorblind, they're not going to see that change that they're looking for, and they might overdo it or underdo it because they can't visually see what's going on. At the high school level, one of the basic reactions that happens that's a color change is it's actually two very clear liquids that you mix together and they turn yellow. And if somebody has a yellow color blindness, they can't see it. I actually experienced this in one of my clinicals. The student couldn't see that it turned yellow, and we had to find a way for them to interpret the data, and it turned out that because the liquids also became more gel-like, they were able to interpret it that way. Finding these different ways of interpreting are a little bit easier for colorblind than for blind or low vision. There are many apps such as Colorblind Pal or Color Assist Light that can read aloud the colors when they are taking a picture of using the app, and that is very useful for colorblind students, because if you have full color blindness, which is very, very rare, all you see is black and white, you can get a that's yellow, that's pale blue, and those are colors are extremely important in the respect that they do have to deal with how the elements are interacting with each other. The reason this is important is because if you have a class size of 1,000 students, split 50-50, 500 male, 500 female, 3 of the females are possibly going to be colorblind, and 40 of the males are possibly going to be colorblind. And that may not seem like a lot, but that's a lot of students who are going to not get the correct experience of chemistry. They're going to struggle, and they're going to not like it. In the Casey Wright article, this is pointed out through the example I just used, and Wright also found that the color vision deficiency was very underreported, and thus it was underrepresented in how much aid was given to these students who needed it. Because of this, Wright concluded that universally designed learning needed to be implemented across the whole of chemistry, whether it's in the labs or the classwork, so that students with any vision deficiency could participate and be part of the science learning environment and be encouraged to possibly follow that as a career. The last thing that the articles also pointed out is the fact that these aids, while they are available, they're not universal. You don't see the aids pointed out in chemistry classrooms. They're all done on an individual basis, and for some students that might not be helpful because they might not know about the aid and they really, really need it. To end this, blindness, low vision, color blindness are all things that happen to students, and anybody that will be teaching a science lesson and all that, these articles I hope will help you understand how to possibly implement some changes to your science classes. So maybe if you have a student with a vision impairment, they'll be able to participate and be a part of the laboratory experience. Thank you for listening to my presentation. I hope you walk away with some ideas of how you can help students with vision disabilities in a science classroom if you have to. Maybe you have developed some questions that are inquiry-based that maybe you can explore and help develop, some of these professionally done instruments so that blind students can use them.